Okay, welcome to video number 1 on thermochemistry. And in this video, we start the unit by talking about temperature and heat energy. These are two really fundamental concepts that we have to explore and define and make sure that we have a good feel for these things. So first, let's talk about a scenario involving temperature and heat. And we're doing this because in sort of everyday language, a lot of times we sort of talk about temperature and heat almost interchangeably, like they're synonyms, but they're actually in science they're quite different. And here's a situation that I hope will kind of illustrate the difference. All right, so on the left side, you're seeing a little thimble, and we're going to imagine that the thimble is full of boiling hot water. So it's water at 100 degrees Celsius. And on the right, we have a tea kettle, which is also full of boiling water at 100 degrees Celsius. So same substance, it's water in both containers. The water is at the exact same temperature. Okay, so temperature is the same. And in order to kind of highlight the difference between temperature and heat, I'm going to pose the following question. So if you're sitting in a restaurant and you had to choose between the waiter accidentally spilling a thimbleful of boiling water on your lap versus an entire tea kettle of boiling water, which one would you choose? And I think it's obvious nobody wants to have an entire tea kettle dumped on their lap when it's filled with boiling water. And the question is why? It's obvious, seems obvious, but in terms of science concepts, why would you rather have the thimble dumped in your lap? And I think just from everyday experience, you probably realize that having the more boiling water that spills on you, the more damage it's going to do, right? Because it contains more, a larger quantity of energy, heat energy, that would be imparted to your skin and your body. So that's just kind of one sort of frivolous example. Now, let's try to nail these things down a little bit more precisely. So, heat, as opposed to temperature, is the total kinetic energy of all the particles in a sample of matter. So if you go back to the tea kettle, the heat contained by the water is sort of the sum total of all the kinetic energy of the water molecules in that tea kettle. And so of course you can see that, since the thimble contains far fewer water molecules, it's going to, in terms of total kinetic energy, the thimble is going to have a lot less heat. And another thing, you may remember this term, extensive property versus intensive. So heat would be considered an extensive property, kind of like mass and volume. The more stuff you have, the more heat you have, just like mass. The more stuff you have, the larger the mass. Now temperature, by contrast, it's not the total kinetic energy, it is the average kinetic energy of the particles in a sample. So here, temperature doesn't care about how much material you have. It simply, it's a measure of the average across all the particles in a sample of matter. And so in that sense, it's an intensive property, like density or viscosity, right? It really doesn't matter how much gold, well, maybe that's a bad example. I would love to have a lot of gold, but it doesn't matter how much water you have. The density, no matter where you measure it, it's going to be the same. And another spin on heat, just to kind of try to give you a fuller picture. Heat's a form of energy that will transfer between objects when they're at different temperatures. Okay, all right. So now that takes us to another situation, another scenario. Let's say you've got a husband and a wife, and they're holding hands, and let's say that the husband is running a bit of a fever, so he's running a little bit hot. He's definitely at a higher temperature than his wife. Well, if if the man is at a higher temperature than the wife, then of course, T temperature of, object 1, which is the husband here, is greater than the temperature of the wife, T2. And if that's the case, from the definition page that we just saw, we know that heat will flow from the hotter object to the cooler object. So heat is going to flow through the man's hand into his wife's body. And in the process, she will warm up a little bit and he'll cool down a little bit. Now, if I were to ask you the question, is this an exothermic or an endothermic process? What would you say? Okay, so as you thought about it, hopefully you were coming to the conclusion that, well, it kind of depends on who you're talking about, right? So if we define the husband as the system, okay, so the word system is actually that's a precise term that's used in thermochemistry and thermodynamics in general, to define the part of the world that we're talking about. So if we define the husband as sort of our point of reference, the system, then from his perspective, he's losing heat. And so do you remember whether that would be an exothermic or endothermic? If you said exothermic, you're right. So you can kind of remember that by thinking of heat like, say, your breath. When you exhale, breath is coming out of your body. So in an exothermic process, heat is flowing out of your body. Now, okay, so that makes that exothermic. Now, on the other hand, if we look at things from the wife's point of view, if we make her the, quote, system, then from her vantage point, she's absorbing heat, right? Heat's flowing into her body, into the system, and so that would be endothermic, right? And as a result, she's going to get warmer. So that's another thing that we need to remember is when an object absorbs heat, the temperature tends to go up. Okay. All right. So let's try to summarize all of this in the following slide. So let's say you have two objects, object 1, object 2. If there is a temperature difference between these two objects and you then bring them into contact with each other, heat will flow by definition, and it flows from the warmer object to the cooler object, and it will flow until the two temperatures become equal, and that's what we call thermal equilibrium. Okay. Now the question is, how will the temperature change in each of these objects? That is, will the temperature go up or down in object 1 and object 2? Well, I think, well, first, let me just define what delta T means. So in thermochemistry, throughout this unit, when we use the symbol delta T, it has a very specific definition. It is the final temperature minus the initial temperature. Okay, and that's important. So going back to these two objects, the temperature of the first object was higher initially, and so when the heat flows from object 1 to object 2, the delta T is going to be negative because the temperature goes down on object 1. Conversely, because the second object received heat, then its change in temperature is going to be positive. Its temperature is going to go up. All right, and I think that it seems very intuitive, right? If you lose heat, your temperature is going to go down. If you gain heat, your temperature is going to go up. But the delta T formalism just kind of, as I said, formalizes all of this. Okay, so let's wrap this all up, and I want to give you a table that I think this would be a very good thing to have in your notes. Because I think it summarizes a lot of information in a compact space, and it'll clear a lot of things up. So I'm representing any generic object as just a circle. And so when heat is flowing out of an object, that is an exothermic process. The sign there, the Q is the symbol that we used to denote heat. And when you're losing heat, the sign of Q is negative. And so is the delta T. So when you lose heat, your temperature is going to go down, and so delta T is negative. All right. Now let's look at the converse. In a process where an object or a system is absorbing heat, okay, it's receiving heat. That is an endothermic process. And if an object is gaining heat, can you guess what the sign of Q will be? That's right, it'll be positive. And if you're absorbing heat, your temperature is going to go up, right? And so delta T is going to be positive. Okay, so that is sort of in one table a summary of many of the concepts that that are really important for thermochemistry. Okay, thank you very much.